So welcome to another video, and then we are looking at Newton's second law. This is from past paper written in 2019 as a common test in KZN. Right, so we're given this system of boxes A and B. Now if you take a look, this is contrary to what we used to, where we have two boxes and then they are connected via a string. In this case, they're not, they're just touching each other. So this means we must pay special attention to this interface here where they touch each other, right? But we'll get to that in a minute. For now, let's just read the instruction. So we have two boxes, masses 8 and 4 kilogram respectively. Okay, it's even in the diagram itself. They are placed in contact. So they are touching each other on a horizontal rough surface. Rough surface means there's friction. We don't know what friction it is yet, whether it's static or kinetic friction, but let's keep reading. And then there's a horizontal force of magnitude F that is applied to box A. Okay, that's also evident on our diagram. And then the system accelerates uniformly to the right. So now we can be sure that this friction that we have is in fact kinetic friction, because this system is actually accelerating, which means it's moving, right? And kinetic friction is associated with systems that are moving. Okay, so now we have that, and then the net force acting on block B during its motion is 12.5. Okay, so for block B we have a net force of 12.5. Interesting. So we can say Fnet for block B, so that you don't forget, because you can forget and start using this net force for block A or for the whole system of blocks. You don't need that. So you annotate it like that so that you don't forget. Now we have that, and then the coefficient of kinetic friction between each block and the surface is 0.2. Okay, so each block has the same coefficient of kinetic friction, so we can just write it as that is 0.2. So now let's interpret this question. So as I was saying, we must pay careful attention here. Let's start with block B. If we go to block B and we draw all forces that are on block B, we're not doing the free body yet, we're just annotating it like we always do. We annotate. So let me show you. So let's annotate and interpret the question. And then we have a system of blocks. We have block A and block B. So if I have block A, let me come back here. Block B. Let's start with block B. And I'm concerned with the forces on block B. Right, you'll get a normal force there, which is the surface applying a force on B. And then you'll get a weight. Okay, it's just a rough thing you would do on your question paper just to get an idea. But here, before we get there, you would also get friction, kinetic friction. But here at the interface, what happens is there will be a contact force between A and B. So let's see if we can sketch it that side. This contact force will be equal. It will be common between these two blocks. So let's sketch it here so that I leave space. Right, so this is our block B, right? And we're saying that we will draw all these forces. Right, so these are all the forces that we will see on block B. Let me just fix this. I call this NB, just means the normal force on B. And I call this weight B, just means the weight on B. Notice I added this one, FC. This is the contact force I was telling you about. So in this case, it's going towards B because it's the contact force exerted by block A on block B, right? So I'll call it FC, just means F contact in our case. All right, so it'll be exerted on block B by block A. But what happens is, according to Newton's third law, block B will exert the very same amount of force on block A, right, but in the opposite direction. So let's draw what it would look like for block A, and we will include all these forces, right? I mean, yeah, all these forces. Right, before we do that, let's annotate block A. It will also have an normal force, NA, and the weight A. And then it will have kinetic friction, and then there will be this force here at the interface between A and B. So let's come and sketch it here. And then we said it will be opposite but equal to the one that you see on B, okay? So we can just sketch block A. Alright, so I've annotated all these forces, and then now let me add the contact force. It will be the same magnitude but to the opposite direction. This is our FC. So both these blocks share this same amount of force. Right, so from here onwards we can just draw our free body diagrams for these blocks. And then remember, let me just write our other. Okay, the relative sizes look bad, but B is not this small according to our let me see, much better. Right, so now let's remember to also state what we're given. So here we're told that Fnet is 12.5 newtons for block B, and then for the overall system the kinetic friction is 0.2. All right, so now let's do our free body diagram, and then we can proceed and start answering the question. And now we have, let me just divide it in half here. All right, so we have that. We divided it in half. There's block A on the left and block B on the right. Now we can draw our free body diagrams. Basically, we're just doing everything we did here, but now into a free body diagram, because remember, we can't leave it like that in physics. But this is something you would do on a rough sheet of paper. My dot looks ugly. So something you would do on your rough worksheet of paper, yeah, where you do your rough work, or even on the question paper itself, wherever there's space. You're just interpreting the question, you haven't even started yet. So now you have your NA, you have your weight, and after that you get your kinetic friction. Looks weird. And then you also get FC, the contact force. And then you get the applied force, the force that is being applied on block A, okay? We call it F. It's called F in the problem. So we just continue with that annotation, or with that convention. So now we do block B. Block B, you would have NB, you would have weight B, you would then have FC going that way, the contact, this is the contact force, not the applied force, and then you have FK. Good. So now we have everything that we need, to answer any other question that will follow after this one, okay? So let us start with our questions. The first question asks us to find, or to state, the Newton's second law of motion in words. Keyword is in words, right? So we are told to state it in words, and then by now you should know it off by heart. Just means whenever a net force is being applied on an object, the object will tend to accelerate in the direction of that net force with an acceleration that is directly proportional to the net force, but inversely proportional to the mass of that specific object. It's usually one of the easiest ones to remember in physics, right? So that's all you would state. Right, so I've already stated it. And then, yes, this is what you would say. The keywords are important, directly proportional to the net force, inversely proportional to the mass, and so on. Right, so let's go to 3.2. Now for 3.2, we're asked to draw a labeled free body diagram to show all the horizontal forces. Oh, this one is a special instruction, to show all the horizontal forces acting on block B, and it's 2 marks. So if you check the one that we have for block B, the one we prepared before answering these questions, we found that it is, let's see, it has 4 forces. So if it was the normal question where they just ask you for a normal free body diagram, it was supposed to be 4 marks, but instead it's 2 marks, which means the special instruction is that you must only include these. But that's what you do. So in our case, we already have done it. We can just take our free body diagram and go put it in 3.2. Okay, so let's just do 3.2 on the other side. Let's say (3.2). Then we'll paste our free body diagram. Right, so what will happen here, assuming you include all these forces, the examiner will be looking for these 2, right? So now, if let's say you had all these forces and you forgot to include this one, it doesn't mean they'll give you 3 marks. You will just get 1 mark, because they are specifically looking for the horizontal forces. Okay, so my diagram looks a bit skewed. Let's try and make it straight. So we'll have FC, and then we will have, yes, much better, FK. Yes, so that's how it would look like, the free body diagram, right? And then now we go to 3.1. We're asked to find the acceleration of the system. This is a 3-mark question. So if you remember, in our typical 2-block systems that we've dealt with, we usually have a string attached to both to connect these 2 blocks, and then sometimes we need to solve for the acceleration using the simultaneous equations, and that is usually a 6-mark question, and so on, sometimes 7. In this case, it's just 3 marks. It means you must pay careful attention here. If you remember, at the start we were given this Fnet. It is for block B, and if you remember our formula, we can say Fnet is equals to MA, but in this case we're concerned with block B, right? Now we are told to take right as positive, and then the net force is given as positive 12.5, lucky us, and then we have the mass of block B being, is it 8 or 4, or it's 4 kilograms, so that's 4A. Then from here you can simply divide by 4 both sides, then your A should be 3.125, but you can round it off to 3.13 meters per square second. Right, so this is our acceleration. See, 3 marks done. Okay, so formula, substitution, and answer, or formula, answer with units, depends on how they're marking. Now that's how you would answer that one. Now let's check 3.3.2. You have the magnitude of the kinetic frictional force acting on block B. That's what they want, the magnitude of the kinetic frictional force acting on block B. Where's our block B? There it is. So now if you remember, and this is also another 3-mark question, Fk is mu k times normal force. In this case, along our vertical axis we only have two forces, the normal force and the weight. So it means normal force is simply going to be equals to weight, right? So which is just mg, right? So therefore when we come here we can simply say u times our mg, and then we were told that our mu is 0.2, our mg is 4 times 9.8. This gives us 7.84 newtons. Good. Is it for the 8 kilogram block? Oh yes, it's for the 4 kilogram block. So that's fine. We are good. We are doing very well there. And then now we continue. We continue to the last question. We are asked to find the magnitude of the force that block A exerts on block B. So basically they are asking us to find this contact force. Right, so if we take Fnet is equals to ma, if you think about it, we don't even need to know acceleration in this case. We have what, 3 point, remember when you're watching a video like this, it's always good practice to pause the video a little whenever you feel like a question, maybe you find it interesting and you want to try it out yourself, and then just try it out and then compare. Right, so now you have this. We know that for block B, Fnet, right, is equals to 12.5. okay, and we know if we take right as positive as told or as dictated by the question, it means we will have Fc, which is going to the right, plus minus our Fk, which is going to the left, because Fk is opposing the direction of motion. That's why it's negative. This means we can say Fc is simply 12.5 plus, because we will transpose this, plus Fk. Then you can substitute if you want 12.5. You have to substitute actually, otherwise you won't find your final answer. Plus 7.84, right? Then what answer is that? 20.34 newtons. That's what you would get. So this is what you would get for their contact force. I like writing the transpose in a different color. So now that's how you would tackle a typical question like this one. Yep, and then let's see. Okay, nothing is left. We are done. So this is how you would get your 13 marks in 2019 KZN March test. So now that's the end of the video. Thank you very much. I will catch you on the next one.